I'm going to copy the function. It's not v, it's obviously v of t. So this is 5,000 and 1 minus 1 over 40t, everything squared, and t is between 0 and 40, but now we have to read all the details carefully. So we have a cylindrical water tank. It holds 5,000 initially, and the water drains from the bottom of the tank in 40 minutes. So first of all, we're talking about gallons. I'm going to take notes. And we're talking about minutes. Okay. And then Torricelli's law gives the volume of water remaining in the tank after t minutes as, and we copied that. Find the rate at which water is draining from the tank after, so part A, t. So this is 5 minutes, 10 minutes, 20, and 40, okay? At what time is the water flowing out the fastest, the slowest, and summarize your findings. So we're talking about the rate at which the water is draining. Okay. So when we're asked to find the rate at which something happens, what am I trying to find? What should I think of?
Instantaneous.
Right? Yes, instantaneous rate of change, which is, what am I really looking for?
Derivative.
Thank you very much. V prime of t. Excellent. Good. So, since the water is draining, does that mean that the volume increases or decreases? Good. So what do you expect the sign of the first derivative to be then?
Negative.
Thank you. Okay, so let's find v prime of t. Can anyone help?
So 2 times 5,000, so that's 10,000.
Thank you.
And that will be, is this still 1 minus 1 over 40t
Good.
times.
Derivative of what's it say?
Good.
So that derivative turns into, is it just negative 1 over 40?
Awesome.
Yeah.
Thank you very much. So this number will go in front. So we have negative. So I will simplify a 0 and then 1,000 divided by, I don't know why. The alarms sounded. I didn't need it, but anyway. So we have 1,000 divided by 4, which is 250. And then I copy the rest. 1 minus 1 over 40t. So far, so good. You can distribute. I would love to see that. So this times this, right? So again, it's 25 over 4t. And this times this will be negative 250. You know me already. I prefer everything in descending order. So negative 250 times negative 1 over 40 will be 25 over 4 with positive, and then t. And this times this is negative 250. I will put this in and then plug in all those numbers. So in the graphing calculator, so back here, clear if you have anything else in y equals. And I will enter in parentheses 25 divided by 4, and then x, and then minus 250. And I get all those numbers right away. So I plug in 5, and then 10, and then 20, and then 40. So go back and highlight. That's the best thing to make sure you get everything. So the first one is negative 218.75. The next is negative 187.5, then negative 125, and then 0. Good. I copy them on paper, and now let's draw some conclusions here. So the question was, when is the tank emptying the fastest?
In the beginning.
Of course. So it should be at 0. They are not asking us to determine at 0, but absolutely, V prime of 0 is negative 250. The measurement unit for all these numbers as well. What is the measurement unit for this?
Gallons per second.
Per minute. Very good. Very good. Awesome. Remember, the rate of change has to have 2 measurement units. One from the top, which is the y value, the measurement unit for the y value over the measurement unit for the x value. In this case, v and t. Good. So then, of course, where is the minimum? So this is the maximum. Maximum flow is when I open up the valve, right? When I remove the stopper. That's exactly it. Where is the smallest rate of change?
20 to 40.
So exactly at 40. Why?
40.
Because the tank is
Empty.
That's it. The tank is empty. How do I know? 40 divided by 40 is 1. 1 minus 1 is 0. 0 times 5,000. This is the rate of change. This is not V, right? But we know that at in 40 minutes you will be completely empty. Good. Okay, let's go back. Not here. I went here. Okay. So this is a long problem. That's why I didn't want to try it last time in the last 5 minutes. So as you see, we have blah, 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 blah. So let's choose a problem.
Professor, I have
Yes.
one question.
Yes.
So V prime. V prime is always equal to S, correct? Speed. Or can it be something?
Yes, it is speed if this is distance. But this is not distance, but it's volume.
Okay.
So because it's volume with respect to time, this is the rate of change of volume at the very beginning when we pull out the stopper when x or t is 0.
Okay.
Better?
Yes.
Okay, very good. Let's continue. Where are we? So I like to start with 1, but you can choose any other function. If we start with the trig function, we can work on the trig function with no difficulty at all. It's just it's going to take a little bit longer. We can do both if that's what you want, or you can choose.
Can you do number 4?
Okay, let's start with number 4. It's a very good pick. So let's do that. So let me copy it. So number 4, we have f of t equals t squared e to negative t. Okay. So let's start from the very beginning. A particle moves according to a law of motion. So this is it, f of t. Of course, time is greater than or equal to 0. T is measured in seconds. And s is measured in feet. Okay. Part A, find the velocity at time t. How do I find the velocity at time t? What do I have to find? Or what are the steps? How do I find v of t?
Would you find the
Distance times time.
This is the distance.
Okay.
This is the distance. Sorry, Isaac, you wanted to say something?
You find the derivative of f.
Of course. By definition, as we just discussed, the derivative of the distance or the instantaneous rate of change, which is the derivative of the distance with respect to time, is the velocity. Good. So now remember, this is a product. This is function 1 and this is function 2. Can anyone apply the product rule and tell us what to write?
2t e to the negative t
Excellent.
plus negative 2t negative e, or
You cannot differentiate again this. We already did, right?
oh, that's okay. Yeah.
Times the inner function prime. Is this okay?
Yes.
Right? So the first function prime is 2t times the second one plus the first function times e to a function prime. Remember, of e to a function prime is e to the function times the function prime. So the function prime is -1. Good. So obviously I will factor out e to -t. And then I have 2t and minus t squared. I realize that I can continue factoring out -t, e to -t, and I have a t minus 2 in parentheses. Let's stop for a second and check all these calculations. -t e to -t times t is -t squared e to -t. -t times e to -t times -2 is positive 2t e to -t. So remember, always simplify, factor, always present everything in descending order. Why? It will be easier for anything else. If we're asked to plug in, we can use the original function that we got, that's fine too. If I'm asked to find the zeros or the x-intercepts of this function, it's so much easier to solve. I see t equals 0 and t equals 2. I'm done. So this is the best form, but of course depends on what we're trying to do. Next, part B. What is the velocity after 1 second? How do I determine the velocity after 1 second?
Plug one in.
That's it. So this is -1 with -1 in front. This becomes 1, right? This is 1, but with minus. This is -1. -1 times -1 is 1. E to -1 is 1 over E. Measurement unit. We can approximate that. I have several ways of determining that. So I either write 1 divided by E. Oh, I didn't mean that. I either write 1 divided by E right here, second and E. That's one option. Or I choose second and E to a power, and I put -1. I don't like that. You know me already. I like parentheses. I don't know that. That's not what I meant. I want this. Okay, it appears like it's a brace, it's not a parenthesis. Okay. So the answer has to be the same. So it's 0.37. Measurement unit. What is the measurement unit? What should I write?
That will be, since we're doing velocity, so is it feet per second?
Feet per second. Awesome. Perfect. Part C. Let me share my screen. Where is it? It's right here. Okay. When is the particle at rest? Particle at rest. What happens when your car is waiting for you in the parking lot? Is it at rest?
Yes, so the
Yes.
velocity is 0.
That's it. V of t equals 0. See, I already had it. When t is 0 and t is 2. Because this can never be 0. So -t e to -t, t minus 2 equals 0. There are only two options, t equals 0, seconds, and t equals 2 seconds. Any questions on this? Don't be shy, please. Okay, so then we know now that v of 0 is 0 and v of 2 is 0. Part D. When is the particle moving in the positive direction? Moving in the positive direction. So the particle is moving in the positive direction, meaning this way, when velocity is positive. Is moving this way in the opposite direction when the velocity is negative. So the question is, when is the particle moving in the positive direction? So I have to look again at the v of t. I'm going to copy it here, which is negative t e to negative t minus 2. So as we know, this is v of t, or f prime of t. And we are talking about, of course, domain for everything, time greater than or equal to 0. Nothing else. And I already have two critical numbers. I have 0 when the velocity is 0, and I have 2 when the velocity is 0. And I need to study the sign of the derivative. So let's plug in 1. And we already know the answer is a positive answer. And let's plug in 10. This is a positive number. This is negative. This is positive, obviously negative. So how will you answer this question? When is the particle moving in the positive direction? So if this is time t equals 0, for 2 seconds, the velocity is positive. And then forever it turns around and it's negative.
Even though it's slowing, potentially slowing down as it gets closer to, we just care that the sign is positive.
We are only looking at the sign. Very good
Okay.
question. It's coming up. So you don't have to write this. Slowing down, speeding up. We are going to talk about these at some point in time. One of the next questions is going to be about that. Do we understand what's happening here? So for the first 2 seconds, between 0 and 2, the particle moves from left to right, and then at this point, at 2 seconds, it turns around, and you will be forever going back. Not back in time, but back. Okay? Good. E. Let's take a look. Find the total distance traveled during the first 6 seconds. Okay, so total distance. So total distance will be the distance going this way between 0 and 2 plus, because we're talking about 0 to 6 seconds. So between 0 and 2 seconds is going this way, plus the distance between 2 seconds and 6 seconds. But we have to write with the absolute value. So regardless in which direction the particle is moving, it accumulates distance. So it went this way between s of 2 minus, it's s or f, same thing, s of 0 in absolute value, which we know it's going to be positive, plus s of 6 minus s of 2, which we know will be negative. That's the reason why we will have to put the absolute value. So s2 minus s1, s2 minus s1, in other words. S of 2 seconds minus s of 0, and s of 6 seconds minus s of 2 seconds. Now we have to determine these values, put them in, and that will be the total distance on 0 to 6. So let's go, where's my function? Here's my function. That's my function. I have to put it in the graphing calculator. So I'm sharing my screen. Go to y equals, clear everything, and we entered x squared. And then we have e to negative x. I don't like this. I like parentheses because not everyone has this type of calculator where parentheses are not required. So I have to show that. And I'm more comfortable putting them in. So we have t squared times e to negative t. Good. So now second and table. And I want to plug in 0, 2, and 6. Good. So now I continue. I'll copy them and I'll show you what I copied. So this is my page 3. The absolute value, s of 2. Let me see. We don't want to take too many digits. Oh, look at that. No, 0.54 is good enough. So 0.54, of course, minus 0 plus s of 6. S of 6, 0.09. 0.09 minus s of 2, which is negative 0.54. Okay, so here it is. S of 2, 0.54, S of 0, 0. S of 6, 0.09 minus S of 2, 0.54. So now we calculate and we apply the absolute value. So 0.54 plus, how much is this? So this is negative point, is it 45? So it's going to be plus because of the absolute value. Well, look at that. Okay, 0.99. Measurement unit. Can anyone give us the measurement unit?
Feet.
Of course. Absolutely, this is feet. So in the first 6 seconds, the particle went 2 seconds this way, 4 seconds this way, and a total distance covered was 0.99 of a foot. Okay, very good. Moving on. Where am I? Here. Okay, this was find the total distance. Draw a diagram, we already did. Okay, so let's draw it again. So that's part F. It starts here, t equals 0. It goes this way, t equals 2 seconds of, okay, and then it turns around and it goes 4 seconds this way. So here is t equals 6. So 2 seconds in this direction, 4 seconds in this direction. G. Find the acceleration at time t and after 1 second. So a of t. How do I find a of t and then later on a of 1?
The acceleration would be the